All right, we're back. This is page 69 of math analysis. We're on a new set of notes. I think it's note 7. And this is going to be about deriving some trig identities and verifying trig identities and using trig identities, just like trig identities. So you've run into identities occasionally. I think in algebra, when you would be solving like a system of equations, and at the end, instead of getting like x equals 5, you just get 5 equals 5. You're like, what the heck is going on? And then what happens is like it turns out that like the things that you were trying to solve are actually the exact same thing. So it's an identity. No matter what you sub in there, you get the same value. So an identity is really just going to be a sentence, well, a mathematical sentence. It's going to be true for every value in the domain. And then you want to kind of contrast that with an equation. So an equation is only going to be true at certain values. There might be an infinite number of them, but there's only certain values. So for example, sine of x is equal to 1/2. If you had to solve the equation sine of x equals 1/2. Well, pi over 6 works, but then so does pi over 6 plus 2 pi, and pi over 6 plus 4 pi, and every time you go around. So pi over 6 plus 2 pi times n, as long as n is an integer. But then there's more, right? Because 5 pi over 6 also works. So then you get 5 pi over 6, but 5 pi over 6 plus 2 pi works, 5 pi over 6 plus 4 pi, and you do the same thing. So that's an equation. It has an infinite number of answers, or it has two types of solutions, an infinite number of solutions. An identity is true for every value. So it'd be like if somehow sine of x always equal 1, always, it didn't matter what x was, that would be an identity. So we don't have that all that often, but in trig you actually do. You have it like a ton. So let's take a look at the fundamental identity. So fundamental identities are called that. There's 3 types. There's reciprocal, and there's 3 of those. There's the ratio identities, and there's 2 of those. And then there is, what color am I going to use here? And then there's the Pythagorean identities, and there's 3 of those. I don't know. They're all pretty much equally important. I think Pythagorean are the, well, you take for granted the reciprocal and the ratio. Pythagorean show up, and when they show up, they're like heavy hitters. Like, you're doing some math when you end up with those. So let's take a look first at the reciprocal identities. So the reciprocal identities, by definition. So we have defined them, right? Cosecant is 1 over sine. Secant is 1 over cosine. Cotangent is 1 over tangent. Like that's how we defined. That's how we define those. So those are identities. Anytime you see cosecant, you can replace it with 1 over sine, which you've been doing probably a ton this year. If you see tangent, you can replace it with 1 over cotangent. You've done that a ton. Well, maybe you haven't done that, but if you saw cotangent, you probably definitely replace it with 1 over tangent. So what we have is, I don't know, let's just do it. So the ratio identities, I guess I should highlight those too. So I've started this highlighting thing. So ratio identities really just have to do with tangent and cotangent. So tangent is sine over cosine. Cotangent is cosine over sine, because cotangent is 1 over tangent. So like you would have to flip it over, but we're gonna do that in a second. So let's just show that the tangent thing is true. We actually know it from a couple of different perspectives. So one of them is definitely a right triangle perspective. So let's draw a right triangle. And I guess, so I'm really guilty of, I don't always do that. I mean, I probably should. So let's say this is theta, this is opposite, this is adjacent, this is hypotenuse, right? So tan of theta is definitely opposite over adjacent. But then sine of theta is opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. So this is kind of like by observation, right? So if I take this and I make it opposite, multiply the top and the bottom by 1 over the hypotenuse. That's essentially what I'm doing here. Multiplying top and bottom, numerator and denominator, I always call them top and the bottom, by 1 over the hypotenuse. We get this, but then this part is actually just sine. So we got sine of theta. And then this part is actually just cosine. And there you go. So when you're done, you draw a little box. And what I usually do is I usually fill it in. I like to do that. But not everyone does that. In fact, I think most people don't do that. I think most people just draw a box, and that's totally fine. Another approach, so this is not the approach that we were asked for, and that's why we didn't do it first. But another approach would be a unit circle approach, right? So this is probably the first place we ran into this. Tangent is y over x. On the unit circle, cosine is x, sine is y. So this is a very unit circle way of thinking about it. And you should pretty much always be thinking the unit circle, right? So when you see this, you got cosine is equal to x, there's an x. And you got sine is equal to y, there's a y. So that means that tangent must be sine of theta over cosine of theta. That's another way of verifying it. So done. So another thing you could do, once you accept, kind of by definition, well, I don't know. Oh yeah, here's what we're doing. I don't know, don't mind me. So cotangent of theta, we know from the reciprocal identity is 1 over the tangent of theta. And we just showed that tangent of theta is sine over cosine. So that must mean that cotan of theta is 1 over sine over cosine. But 1 over sine over cosine is just cosine over sine. And you're done. So you have to decide like where you're willing to start. Like the reciprocal identities are by definition, so like go with those, right? And then from there, you pretty easily can get the ratio identities. So the ratio identities involve tangent and they involve cotangent, and you just want to know those. Tangent is sine over cosine is so important. I mean, I always fall back to thinking about that one instead of thinking about the cotan one. And you hear it when I solve problems. Like if I'm giving cotangent, I immediately say, so tangent is this, therefore cotangent is this. Always fall back on that. But that's actually this whole page. So we're 3 in. No, we're not. Man, what is wrong with me today? We've got the reciprocals. There are 3 of them. You got to remember them. They're by definition. Ratio identities, tangent is sine over cosine, cotangent is cosine over sine. Really, it's the tangent one that like makes it all happen. And then a couple of like verifications or proofs or whatever you want to call them, derivations maybe, whatever. So I'm going to stop this video here. I'll come back in the next video. We're going to deal with a couple more of the fundamental identities. So I will see you there.